Okay, we're about 2 minutes after the hour. I'd like to go ahead and get started. You can see as our opening slide here. I'm wondering if anything has ever happened like this to you before. Of course, this is a little more drastic. It could be different things. Of course, a pump or a motor go out of plant, generators. But we'll be going over today using predictive analytics to help prevent items like this from happening. And today I'd like to welcome Greg Wolf, who will be our primary presenter. He's the president, CEO of Fischer Block. And my name is Evan Heacock. I'm the director of NERC compliance here at Certrec. And we're going to go over looking at trying to cut costs at a power plant using AI and machine learning. Greg's been doing a lot of work with this and has a really good product for this, and be looking to help you folks out there in the world of predictive analytics and looking at causing and not allowing turbines like you saw at the beginning, or plant motors and various equipment from destroying itself prior to it ever getting there. So predictive analytics is a wonderful thing, and Greg has a wonderful tool for that. And go over today challenges, how Fischer Block and Certrec are working together, how predictive analytics can help with challenges, use cases, the ease of installation of Fischer Block, and then also fault recording for NERC compliance, not only just fault recording, but also voltage analysis. A lot of information that's coming out from the different regions these days for inverter-based resources. Go over conclusions, and then Q&A at the end. And for Q&A, you can type in a question along the way, and we'll get to those at the end, but we'd like to have questions at the end of the seminar, if you don't mind. For what we're doing here at Certrec, there's several areas that we're definitely looking into these days. Of course, compliance and SaaS products as a service is one of the main things we work on here at Certrec, which also allows us to work with Fischer Block on this. Also, cybersecurity for utilities is another major area that we're looking at. But today, really, we're looking at digitization. How digitization can help you forecast predictive maintenance in the future, so that you can have a more reliable and system at your plant, whatever it might be. It doesn't have to be power plant. It can be industrial plants for processing. So Certrec, we primarily deal with compliance, so that's why we look at it from generators being safer, but it also definitely can help with industrial as well. And I guess, again, Fischer Block just talks about what they're doing and where they're going. Of course, they are leading asset monitoring solutions, for different areas, not only generation and transmission, as you can see as part of this, but the industrial facilities, motors, pumps, whatever else it might have that turns and is turned by a motor, or in this case, also a turbine turning a generator. Some of the challenges that are faced by utilities today are definitely, there's demands to increase the reliability and efficiency of a facility. Look at equipment health and unknown health issues that you need to make sure you try to catch ahead of time if you can. And then also, because the cost of maintenance is going way up, you want to make sure that you can look at and plan your maintenance properly, so that you don't have unplanned equipment failures that caused unplanned operational downtimes, which cost money, from a generation or product production. Also helps with the reducing the cost. Again, everything is going up so much. You don't want your equipment failing that would push your your outage cost up, your plant cost up, maintenance type items. And then if you have an inability to monitor your plant, that will cause you problems, because it will break on you when you don't expect it to. Something can fail. So we're working to try to help with all those items. And then, of course, some of these that we will help is lack of visibility. If you don't see things coming, it's kind of hard to prepare for them. Limited staff also adds to that. So we have lack of visibility, fewer staff members, and then also knowledge going out the door. All these will increase the chances of predicting and knowing when something's going to happen, but also increased restoration times. It takes longer. You start losing folks and the knowledge. You start having the inability to restore quickly, and which also increases the risk of your product generation and also efficiencies. So one way to overcome challenges with this is to come up with early warning alert so that you can protect against unwanted shutdowns. The predictive analytics reduces unplanned shutdowns by 45%. So if you can have early warning to help you reduce by 45%, then you can help increase your productivity overall. And of course, all that's coming back by management wanting an increase in reliability, availability, right? All this comes back to being able to get your product out the door efficiently and cost effective and meet goals. So all these things fit together and help increase your availability, and it reduces reliance on spreadsheets with having data come into you that's organized in a format that makes sense, as a software as a service type items like we're doing here with at Certrec and also Fischer Block. Gives you more insights and data quickly, so you don't have to go thumbing through it all. The information comes in. If it tells you what you need, then that helps you, and that's where the intelligence comes in from the system. AI will help you get all that information together, and what Fischer Block is doing with a lot of their predictive analytics to get that information to the folks that need it. Maintenance might be engineering type. So all this coming in, putting it together can help you get where you need quicker, faster. With that, I'd like to go ahead and we'll get Greg to chat now. He's got more information than I do.
Thank you, Evans. I really appreciate the opportunity to share our platform and our technology with the group today. So, as Evans has said, Fischer Block, we're focused on predictive analytics and providing visibility and insight to owners, operators of various plants and grid delivery operations, so that catastrophic failures and even minor failures can be detected and avoided. And I personally came out of the portable test and measurement world. I was with one of the largest providers to the industry of portable equipment, and what I found was that many times the portable equipment is used in a kind of a reactive mode to ascertain why things broke, what went wrong, how much of the equipment was affected, what can be put back in service, and so forth. And myself and a team of primarily engineers got together, and 8 years ago, we formed Fischer Block, and we have an online system that in the early days, we really focused on how can we connect a high resolution, high accuracy sensor to control panels and the grid industrial plants in a very non-disruptive way. And we came up with what we call a smart block, which in nearly all instances installs without an outage and any shutdown and without any new wiring. But for the past several years, we've been focused on all of the analytics and the insights that are gleaned from the high resolution data streams. And so we have Wave IQ, which is a server-based application. Most often it runs on our customers' networks behind their firewall. With Certrec, though, we're very happy to be partnering with your team and making Wave IQ available through your portal to provide the insights and the alerts and the advanced notification of pending problems. So very excited to be part of this alliance. And here's just one typical asset. We monitor rotating equipment and also equipment that has no moving parts, breakers and transformers, arresters, and so forth. But what we're focused on is looking at the electrical signals in very high resolution, and much higher, thousands of times higher resolution than a SCADA system, for example. And so we're able to then detect and monitor and trend over time slight subtle distortions in the signal that are caused by, in most often cases, degrading internal components inside these assets. And so we can monitor bearings and gears and winding health, transformer saturations, insulation over time, watch the trends, and provide advanced notice to the operations teams to be able to plan proactively maintenance activities, inspections, and those repairs and inspections are fed back into Wave IQ. It's part of the feedback loop and the learning, so that anytime there is an alert notification on the dashboard, all of the history of that asset and similar assets that have experienced those types of behaviors and conditions are right there at the operator's fingertips, or the engineers or technicians, to make the most informed decisions possible.
So with that, just real quick on the, you said also non-moving parts in electronics. So we're talking about inverters. So you can get signals through, come in from inverters also that would pick up.
Right. One of the main issues with inverters is the harmonic content within the electrical signal. And that's something that NERC and some of the ISOs are really focused on recently, is that in these IBRs, inverter-based resource farms and sites, that the harmonic content needs to be below certain levels. And as well, those inverters sometimes can trip off prematurely before they really should. If there's an event out on the grid, you really don't want the local farm tripping off if it's not to the threshold that it should. And so that's a real focus area. Our platform provides that functionality to ensure that these IBR sites are compliant. But this slide here, it's interesting that both electrical and mechanical issues actually show up in the electrical waveforms. So that if you have a wiring degradation on a rotating piece of equipment, which is really a connection on the rotor, if that's becoming high impedance or beginning to crack, that'll actually affect the magnetic flux and thus the electrical signal. And bearing problems, gears as well. We can see transformers saturating, insulation problems. So a lot of mechanical issues show up in the electrical signal, and all of that then is monitored and trended in our platform, and alerts go out to the authorized roster when it hits a threshold.
Yeah, so this would be what you were talking about just a minute ago with the IBRs, isn't it? The California ISO was actually put out a note to have people start put in DFRs to record this information.
That's right. And PMUs or DFRs, in our view, the DFR is really, you can get PMU data from a DFR, and the DFR then does a whole lot more in terms of high resolution capture of the waveforms via sampling. So we provide all the DFR functionality that satisfies this latest concern and these requirements at ISO, and suggestions and recommendations that they're putting out now.
Yeah, just for folks that don't understand why this may have been put out, there's been some events where a short circuit on a transmission line has caused lots of generation loss from IBRs. It's called the Odessa event here in Texas, and so they're trying to work through what's going on, but be able to figure out what's going on, you have to have recordings first. And of course, Fischer Block has that capability to record the information so they can help diagnose what's going on.
This is another application on a solar farm. So we're monitoring both AC and DC signals depending on the application. One of the challenges on solar farms is detecting and isolating ground faults. Many of these utility scale sites, if there's a ground fault and it trips the inverter, there's so many lines and panels coming into one inverter that many times technicians have to walk several miles just to find the failed panel. And by monitoring each line coming to the inverter in high resolution, we can then detect and isolate ground faults to a very small distance, a few hundred feet. And so that's one of the main use cases for our technology on solar farms. Harmonic distortion is another big issue we talked about a minute ago. And then even just tracking panel health through the life of the panel. You don't want to take a panel out of service before you have to, and you don't want to wait too long either. And so identifying panels that are degrading and then being able to get back to them. Some of these farms, as I said, are miles long of rows, and getting right back to to the panel quickly is something that our geo application provides, which is part of Wave IQ. This is a use case for grid delivery. It's actually a substation on the East Coast, whereby for months, if not years, the utility was challenged with nuisance trips, they call it, where breakers were tripping. It was actually propagating, so that customers on several different feeders were feeling the impact, whether it's flicker or actually an outage. And so we did this implementation without a shutdown, no new wiring. And that was actually a retrofit cover of a Flexi test switch on each panel. And so you can see that third panel from the left doesn't have one of our devices for whatever reason, but you can see that plastic cover. I don't know if you can see my mouse, but we just removed this cover with 2 thumb screws. There you go. And then we installed our device, which is that particular variant was a intelligent test switch cover. So the test switch is not affected. We just install our device with 2 thumb screws. We make contact with the knife blades through ruggedized spring-loaded pins. And we actually replace a mounting bolt on that test switch, one side for Ethernet communication, the other side for a insulated cable to the back. And we snap revenue grade split core CTs over the secondary wiring. So no outage. It took about a day to install these 40. And within 10 days, we captured the first event, and all of our devices talk to each other. So that when one triggers, they all trigger. And we had a 40 Comtrade file sequence of events profile. You can see just a small snippet of it on the right there. And so the engineers were able to very quickly identify what the issues were and therefore take corrective action. So I'm spending a lot of time on this slide, but it has a lot of our features and functionality and benefits in this application.
So as part of that too, when you talk about the little information slide over there, what's the resolution? What are y'all sampling at to get the resolution as high as you do?
Right. Our typical sample rate is 128 samples per cycle, which is well above the minimum to get all of the harmonic content to meet all the IEEE and IEC standards. But what we found is actually varying the sample rate, we can get different resolutions on the frequency spectrum. And so if you slow the sample rate down, but you record for a much longer duration, you actually get increased resolution on the frequency spectrum to isolate down to specific subcomponents that are failing in some of these assets. So it really depends on the application.
Okay.
Okay, yeah, here's a picture on the left. There is kind of behind the panel of what we were just looking at a minute ago, where you can see this insulated tube cable coming through this mounting bolt, and it just terminates into a connector, lays in the tray, and then we snap our split core CTs. They're hinged. They open up and close around the secondary wiring. So it takes about 5 minutes to do that installation. On the right there is an application whereby once in the substation or MCC panel, if you're able to walk to the back, then many times we just install our device right to the back of a panel. We have flat panel mount that just mount right to a steel panel. What we're looking at there is actually mounting our device to the back of a Flexi test switch. So you don't need any mounting bolt swap outs, but we still take advantage of the studs on the back of the test switch. We have spring-loaded pins that make contact. No new real estate is needed on the panel for our device. And then we just plug in a CT probe assembly right there, 3-phase, and then either fiber, Ethernet, or Wi-Fi. We power our device either right off phase power that we're monitoring or power over Ethernet. That's the most common choice of powering our devices that our customers use. That way, if you do lose power on your phase voltages, our device stays on. We can also bring in station DC. And we have a backup battery inside our device anyway, so that if you do lose phase power, our device stays on if we're powering off the phase. So just a couple of examples of how we connect to the grid and industrial and generation plants.
Okay, yeah. So really the big difference between, say, some of the older digital clock recorders and yours is that you don't have near as much wiring. You're not having to break those CT circuits or bring in PT circuits to say the end of that switchgear that we saw on the last slide, right? It's all right here. You're just connecting right away, and there
Right.
you go.
It's like distributed DFR technology in a sense, and our pricing, in our view, is very economical. It's not such that they all add up and it's more than a DFR. But now we have a microprocessor monitoring, learning on each three-phase circuit, very high resolution, very accurate, very high dynamic range. So we're really focused on being not just easy to install, but also state of the art in terms of the technology and the accuracy.
Yeah, I mean, that's actually really nice. And I've said this before, as if I wish these things were around back when I was doing design work and working in power plants and whatnot, because this is so much easier. And I probably could have got this through the folks that handle the money, because it's very easy to put in. There's hardly any cost. There's no really low cost to install. So yeah, it's wonderful from that standpoint.
And it's really helpful in a pilot situation whereby, you maybe in a pilot will embed a set. We have a variant that has an embedded cell modem. So maybe not for production or rollout, but for a pilot, it makes it very easy to install. No outage, no drawings necessarily. Don't need to involve. There's not a lot of IT work. You obviously want to make IT aware of what's going on in a pilot, but very, very quick installation and evaluation of the technology. So I think we have a few use case slides here. Won't spend a lot of time on these, but this is a large rotating equipment here, monitoring high resolution, three-phase volts and current, extracting all those frequency spectrals out of the time series signals. And you see at the top right there is this kind of a snippet of the full spectrum right around the fundamental. So the 60 hertz signals in the center. But many times if you have a degrading rotor cage where the joints from the rotor windings to the ring are either getting hot, high resistance, beginning to crack, we'll see sidebands in the frequency spectrum, plus or minus. It's a function of the slip frequency of the rotational speed versus the grid speed, and we then monitor those spectrals. And when they hit a certain range, a level, approximately 45 dB below the fundamental, then the alerts go out and inspections are carried out. And many times we've been able to avoid catastrophic failure with our customers. And it's very important to have a low noise floor. That's that dynamic range, so that we see these spectrals coming out of the noise months before failure. And then we trend them on a trend chart as well, so that we can then predict when there would be the failure. And so we can make sure action is taken well before.
And as part of that, when you talk about that action, you're basically communicating with the person at the site that's maybe overseeing that, so they can get them involved to start planning an outage instead of having it lost, right? So again, it gets back to that predictive analytics, helping customers do it in a controlled manner and not a chaotic manner.
Right. Like Wave IQ will bring the issues to the top, to the surface on our dashboards, and provide the alert notifications that have been set up. But the users really need to actually take the action and watch the dashboards and watch their alerts. And worldwide, our technical team, if our customers receptive and amenable, we're, as part of our service, we provide that. Now through our alliance with Certrec, you provide that as well. So
yes,
there's more than one set of eyes watching the dashboards typically.
Yep.
This is here is a situation where our software detected harmonics of rotational speed showing up at growing intensity, which is a classic indicator of an alignment problem. The customer went in, got the alert notifications, planned the inspection. When they went in, it turned out wasn't an alignment problem, or else this pinched cable was causing the alignment problem. But the real concern was a pinched cable that was actually arcing as the generator rotated. And so they were able to take action. That could have caused a fire, and a lot of heat was being generated. And so now that has been fed back into Wave IQ. So anytime we see that type of frequency spectrum, not only is the suggested cause an alignment issue, but also could be pinch cable. So watch for that as well. And all our customers on the program benefit from this learning. So what we learn in one city, one implementation, anyone on the program gets the value of that learning, and they can leverage that. And so we're not necessarily sharing customer data between customers, but insights that we've gleaned, just helps the whole industry. And here's a situation where a capacitor bank switch controller was degrading. The timing was not what it should have been. And so cap banks were being switched in and out at places on the signal other than at zero crossings. You would ideally want to switch cap banks in and out at zero crossings when the voltage is low and the current is at near zero, to minimize arcing inside the cap bank. If the timing's off, then you're getting arcing and pitting on those contacts, and eventually they'll fail. And so on the bottom left is a snippet out of an IEEE paper that talks about cap bank timing problems. And in the middle there is a waveform right out Wave IQ, where we detected that and helped the customer avoid failure. And here's an example, no moving parts necessarily, but a lightning arrestor was degrading. At the top there is transients in the RMS signal. So the RMS is basically a flat line in a perfect world, just what basically the average voltage level is, or current. And seeing transients and spikes in the RMS signal is, typically pretty a violent situation if it's showing up in the RMS signal. Probably wouldn't be seen in SCADA, because SCADA is more of a very low resolution, once every few seconds, where these are happening very quickly, a fraction of a second. And so eventually, though, no action was taken for whatever reason by this customer. Eventually there was a breaker trip, and our platform caught that as well. That's the bottom. So that's a very short duration waveform capture. We typically will capture 10 or 11 seconds, 1 minute pre-event, 10 seconds post. So we're giving 600 cycles post-event. And normally you don't need that many cycles. In this case, though, the breaker tripped after about 30 cycles. And so there was an issue there with either the relay or the communication or the breaker. So many times we'll be able to uncover relay issues, breaker issues that we can see during a trip event. And so leading up to it and the breaker trip, valuable information is gleaned from these high resolution captures. And recently we just launched this at the IEEE Grid Edge conference in San Diego in March, a couple months ago, whereby now we're ingesting real-time video feeds, both regular camera, day and nighttime cameras, as well as thermal imagery, into Wave IQ. So it doesn't go into the smart blocks, it comes directly into Wave IQ. Wave IQ, then the module, vision module, is analyzing every frame of the video and looking for what it's been trained to look for, in most cases, hotspots and arcing. Some of our customers actually use it for security, humans at a fence or a car at a gate. Wave IQ can alert on that and provide notice to the authorized user list that there's the object has been detected, target object has been detected. And so what we're doing now, though, is when Wave IQ does see that object, in this case a hotspot, it triggers all of the smart blocks in that vicinity. And so we're actually capturing electrical signals synchronously with arcing and hotspot, so that we're able to build a event library without having to wait for breaker trips. And so we're in an accelerated way with some of our customer partners. We're building this electrical signature library associated with hotspots and arcing, so that in areas where we don't have video feeds, we can still identify potential hotspots and arcing based on electrical signature analysis, real-time monitoring and alert notifications.
I can imagine that the doing the hotspot is especially for remote locations, is a really advantageous type function. It's hard to get people out there in a hurry if something's starting to go wrong. So the hotspot indicator is actually really handy. I think and again, the utilities do it ever so often. They look for hotspot, but this sounds like it's continuous, which is very advantageous.
Yeah. Online continuous monitoring, yes, 24/7. So I guess, just on that issue, the ease of installation is has always been kind of the backbone of the hardware side. The analytics, though, is really provides the full value. And even on panels where there's microprocessor based relays, where there is a waveform capture upon breaker trip, our focus is not just also capturing that breaker trip signal, but waveform, but providing predictive analytics for the days, weeks, and months leading up to failure. Many times the relays aren't performing those functions. They're mainly focused on tripping breakers when they need to be tripped. We're focused on providing predictive analytics to avoid the breaker trip. So many times our customers have our devices on panels where they already have microprocessor relays.
Yeah, that's again the nicety of Fischer Block is that information you can just extract it with installed devices and not really have to do a whole lot more. That's just, and it's so handy. It's again so easy to install. Mm-hmm. And then the other part of that too is, like we talked about, is getting the information out. Between Fischer Block and our portal, you can get information anywhere through our secure portal. All of our data as it's transferred is encrypted in transit and at rest, and you can access it pretty much anywhere, on your phone, smartphones, or at your desk.
And I'll just make one comment on that. We recently had a customer that attended one of these webinars, and then we had a follow-up meeting with them where they came and actually visited our facility and met with our technical team. And now they're recommending this platform not only to their company, but some of their partner companies as well. So, this full value, holistic monitoring, we really see more and more companies thinking in a proactive way. And we used to really have to push our message, our solution years ago, and now it's being pulled in a lot of cases from our company.
Yeah, it's pushing its own way around. Yeah, predictive analytics, right. Yeah, it's a big thing, especially in large facilities, and you're trying to monitor everything. Having all that data come in, be able to use it intelligently is a wonderful thing. And also, part of it is that it has also capability of meeting some of the NERC compliance requirements for those that have to meet those out there on the webinar today. And as he said, it does fault recording, it does sequence of events recording, it does fault recording, and it does help and record the dynamic disturbance recording also that's necessary by PRC2 there. So it actually fulfills all those requirements easily. Again, simple to put in. You just for those, for PRC2, you don't need too many. You just need one. Of course, for all your monitoring your motors, you want to do more of that for predictive analytics. But it can also help keep an eye on your voltages for VAR2 and make sure that they stay compliant in case there's not any easy information coming in for VAR2. And that gives you a little different range of alarms. So this can also be used, obviously, for NERC compliance. So in the end, really, we're looking to improve the return on investment from folks, and predictive analytics will definitely help you get there from that standpoint by predictability. As you're having rotating equipment that starts showing issues like Greg has talked about, you can do a planned shutdown instead of having an emergent issue and losing production time. You can schedule it properly. You can get your equipment in as necessary, for replacement, whoever it might be, and do it in an organized instead of a haphazard way. So that then goes right into helping with reliability and visibility. It increases those. Also, we end up having increasing compliance stuff from NERC and some of the other folks out there in the world. ISOs have put it in. We talked about that from California ISO, looking to have information come in on inverter-based resources, and then which also again reduces risk in the end. But for next steps, how can we help you? Get in touch with us. we'd like to talk to you. I know Greg and myself and others would love to talk to you as necessary if you're more interested in the product. And I think we go to
we can set up a private webinar, one-on-one with any interested team and go through more detail in terms of the applications and the platform.
Yep. With that, we have open for questions. And again, you can ask them by unmuting or if any are out there. Brandon, we have any questions?
I'm not seeing any just yet.
Okay. Anybody out there has any questions they'd like to ask?
Yeah, this is Bob Johnston. I'm with VHE Renewables. I manage a large solar site in Southern California, and we have some significant issues with ABB inverter IGBT failures, and the current SCADA system doesn't predict it. And when they fail, they tend to cause significant damage in the inverter. And I was just wondering if the WaveQ would be able to predict an upcoming IGBT failure.
That's a great question. We've started with the solar farm monitoring, focused on the DC side and the tracking panel health. We do, though, have a couple implementations that we're just now putting in with some customer partners, where we're now monitoring both the AC and the DC side, the inverters, and the IGBTs are going to be part of what we're going to be looking for in terms of early fault detection. So we'd be very happy to have a follow-up call with you and learn more about what your challenges are, and see if we could set up a pilot to actually help you detect and predict failures in that way. So we'll have more on that as we go forward, but that's becoming a growing concern and challenge that we hear from our solar related customer base.
We had some folks that weren't able to join the call today. Would you be able to provide us with this presentation?
Yes, absolutely. This webinar is being recorded right now. I can send that over to you.
Oh, great. Thank you.
Yes, please. This is Roy from Wolf Creek Nuclear Power Plant, and I'll appreciate if you can send me also the presentation. That was a great information. I'll appreciate that.
Yeah, I believe we'll be also posting it on our website, the Certrec website. Also, they should be able to get there, but we'll definitely get it to you.
Yep.
Thank you.
Mm-hmm. Any other questions out there? We're trying to stump Greg today, by the way. So throw your best question.
It's funny because some of these webinars, there's so many questions we have to cut it short, but and then others it's the opposite.
And so we kind of talked about the information and how fast it samples. And one of the things you did say is you do sample and change your sample. And if you would kind of go back over that just a little bit to say why you do that, why you have your increased sampling or decreased sampling.
Right. Well, if as some of the audience may know, the time series signal, like the sine wave, a voltage or current signal, when you sample that, you're sampling at a certain rate. And the faster you sample, then the higher the frequencies you can detect. I mean, that's fairly intuitive, right? So, and there's a rule of thumb, there's a Nyquist theorem that you have to sample at twice the rate at which you want to measure up to. So if you want to see up to 3 kilohertz, then you have to be sampling at 6 kilohertz. And on that frequency spectrum, you get basically a frequency, a little line. It represents the magnitude of the distortion at a given frequency. And however many lines there are on that spectral between, say, 0 and 3,000 hertz, however many lines are, that's the resolution that you have. And so if you slow your frequency, your sample rate down, let's say you sample it now 1,000 hertz, Well, if you sample now, instead of 3,000 or 6,000, you're down to 1, but you sample for 6 times longer. In terms of the number of samples, you're still going to have the same amount of spectral components, but instead of being stretched across 3 kilohertz, you're stretched across 500 hertz. So you have much higher resolution now. The same number of spectral components, but it's over a shorter frequency band. So that's not that intuitive to people. When they hear that, if you slow your sample rate down, that you actually get higher frequency resolution. And that's only true if you sample for a longer duration so that you get the same number of samples. So it ends up being then higher resolution. So hopefully that made sense to some of the folks out there. It can be confusing.
Just another curiosity for when you've done pilot, Greg, has there been something that stood out more for the request by some of your clients that said, we like to look at certain types of things, equipment pieces, is there something out there that you've seen?
Yeah, I mean, in terms of setting up a pilot, we'll typically, it depends on what the application is. If it's delivery, whether it's transmission or distribution, or if it's generation, either a plant or an IBR or industrial plant. We will typically set up our devices to provide the full gamut of features so that we'll vary the sample, we'll configure the unit where it does this automatically. So it will, like, throughout different parts of the day or under different environmental or load conditions, it will change sample, our device changes sample rates so that we actually get high resolution and lower frequency range, and then a little bit less resolution but higher frequency range. And so therefore at the end of the pilot or throughout the pilot, we have a real full holistic view, if you will, of the performance of that asset or operation. And then the more we learn from a given site and an asset, then we'll end up typically modifying the configuration to what makes sense for that operation, that customer.
Okay, thanks for that. Anybody else out there have any other questions?
Yeah, this is Bob again. I just one quick question, and I might have missed it in the presentation. The data that is being monitored, is it being monitored or sent into the existing SCADA system, or does Certrec monitor it and alert the site? How does that work?
Well, the first level is the smart blocks are doing 100% high resolution waveform sampling. However, the smart block devices are not sending continuous waveform data to WaveIQ, our software application. The smart blocks will decide what's when there's items of interest where waveform captures are made, and then we send those waveforms files to WaveIQ. They're converted to ComTrade format. In parallel, our devices also can send information to an existing third-party SCADA system, whether it be SCADA data or just a binary flag that says that an event has happened and there's waveform data within WaveIQ. And then all that's from WaveIQ is available through the Certrec portal. And I'm not sure if the Certrec portal, how many times that's been integrated in with a SCADA system, but WaveIQ can integrate with a SCADA system.
Okay, thank you. That's helpful.
Yeah, hi, gentlemen. This is Eric White, also with BHE Renewables. Just a quick question regarding calibration / maintenance aspects of those edge devices. I know for typical Tesla units or DFR recording, you want to do recurring maintenance or configuration. What's the relationship with that with these devices?
Right. We're recommending 3 to 5 years on calibration. We've had, as I said, our company started about 8 years ago, and it took us about 3 years to develop the platform. And so we launched our product about 5 years ago in 2018. And so we've been monitoring the accuracy and field calibration processes, and we haven't seen an issue in terms of any recurring issue with calibration. And so we're recommending 5 years, and we have some customers that have scheduled it on 3 years. And so, and we're trying to automate that as well, so that most of it can be done from remote.
Great. Yeah, that was my next question is who would be able to do that? And I assume, would this be under kind of a maintenance contract? And I apologize if you covered it early. I joined a little late.
No, no problem at all. Yes, we have the Wave IQ is it's like a licensed service, but part of that is the 24/7 tech support and the data analysis and the Wave IQ support, but also the field calibration, the automated portion of that. And it's typically the customer technician would go out and either verify a known level of the volts or current, and there's a small button on the device. They can press that button, and then everything else is done from remote at that point.
Gotcha. Great. Thank you.
Mm-hmm.
So any other questions out there? So can you talk about field services? Question came in.
Right. Yeah. I mean, we just touched on a bit, but other than calibration, we haven't seen we've got thousands of these devices out there, and we've had single digits come back for any type of it's interesting. Our team came out of the portable test equipment world, and portable test equipment, it's interesting because it has to provide the electrical signal and the monitoring of the response of the asset. You typically take an asset offline, and then you bring portable equipment in to provide a signal and monitor the response. Online monitoring that we're doing, we don't have to provide the signal. That's the grid, right? And so we're really doing a low current, you can monitor volts and just bring microamps into our device. So it's very low stress on our device. And so we have had very minimal field service requirements. However, we have a growing network of partners, and Certrec's a great partner to provide any local support that anybody might need.
Okay, any other questions? I'm not hearing any. I wanted well, there we go. One other one. Can a customer install the Fischer block?
All right, that's it. That's a great question. Typically on an implementation, our team will go out, 1 or 2 people, and either do the installation and train the customer's technicians, or we observe and we do the training and they do the installation, and we observe them doing it. Their policies are such, or they desire to do the install themselves. And so, yes, these can be installed with no tools, and without an outage, without any wiring. So it's very it's very well within the capabilities and skill sets that customer technicians currently have.
And I did see a question that popped up of whether or not this the device was in QA1 of software, and that kind of gets back to a nuclear question. Nuclear folks out there, this is not a safety related product at this time. It can be installed in the nuclear plants on the non-safety circuits, for all the BO balance of plants type stuff, but not from a safety function at this time. I won't make Greg answer that question. We can talk to him offline and see if there's any plans to ever go down that path or not. But at this time, it's not a safety related product that can be used in nuclear plants under Appendix B. Any other questions? I've definitely had a lot of good ones today there, Greg. I haven't stumped you yet.
Yeah, great session. I really appreciate everyone's time and interest. Thank you.
Okay. Without hearing more or seeing more questions, I'll say thanks again to Greg and being here with us today. And here's some information on how to contact us. And I know I did see some information pop up on how to find these on YouTube. You can find actually this webinar on the YouTube, but you can also come in at certrec.com and set up a consultation down the road. Greg and us would be definitely happy to help you with your needs. I can't say enough about how good it is. It really is a really great product. And again, being in the industry in the past, I remember how much fun it was trying to bring in a device to set this up and take an outage to figure it out. And this way you don't have to. You can put it in and then it starts monitoring for you, and it'll help you out in the long run. So again, thank you, Greg, and others joining us, and hope to talk to you folks in the future. Thank you.
Thank you. Appreciate it.